Hi everyone, we work with Gordon Engineering. Our mentors are Bill Junda and Pete Lazarovich. Back over here. My name is James McNamara.
Lawrence Osborne.
Andrew Coggin.
Jared Tamulinas.
Our site is located in Northern Virginia in Chantilly. It's just off of Route 50, where John Mosby Highway. It's approximately a 17.5-acre site. It's outlined here by the tree line, and then bordered by Valley Vista Lane to the south and Poland Road to the east. We're given deliverables. We're a multifamily residential unit with 222 townhomes. Each townhome is approximately 2 stories, and one unit consists of 2 townhomes for 4 floors per unit. And then several other deliverables included a clubhouse and a pool for the complex.
Alright, so some goals of the first learning module were to develop a site that contained 111 townhomes, which is 222 units. We had to prepare 2 layouts, essentially slightly different, compare and contrast the differences between them. And ultimately, Bill and Pete picked which one they liked better for us to go forward with. We had to use most of the land given, and we had to follow Loudoun County and State of Virginia ordinances and facility standard manual to do setbacks, stuff like that. We had to provide sufficient space for parking and include a neighborhood clubhouse and pool. Our feasibility study consisted of discovering that it was R16 zoning, which is effective for this type of development. It is currently undeveloped, as we saw before. One of the main things we needed was a tree buffer along the bottom, because the people that live on the bottom want a tree buffer for sound and vision of the new development. And there is an existing wetland in the bottom corner. So existing constraints, slopes, our site is completely developable, which is good for our grading and drainage. We do have utilities in the top left corner. We have water and sewer. And then on the right, on Poland Road, we have just water. And then in the bottom corner by the sediment pond, we have sewer. So this is layout 1. Essentially, we have a court in the bottom corner with the clubhouse there. And that was our first layout. Our second layout is pretty similar, but instead it's more linear with a couple of dead ends. This is the one that they told us to go forward with, so this will be the rest focus. And this is the final layout. What we changed from the last picture was we added more parking, a lot of visitor spots for people, and we connected 90 degrees to the roads for the property. Our layout is essentially 3 buildings to 8 building clusters. So we have multiple clusters. The home sizes are 25 by 49, and there are 4 stories total, 2 stories, 2 to 2-story buildings with 2 garages on the bottom, 1 for each townhome. And then entrances, we have 2 entrances from Defender Drive and Poland Road, as we saw previously. 2 parking spaces per household, 1 in the driveway and 1 in the garage, and then 111 additional parking spaces for visitors. Lot coverage was to be 60%, developed 40% green space, and we're just about exactly that, which is good.
So the second module is predominantly based on grading. We had to fully develop the layout of the roads and the buildings that would follow suit after that. So as such, we create the full grading plan, and we had to follow grading guidelines to prevent ponding and that sort of thing throughout the whole site. And our site flowed from the northeast corner to the southwest and the southeast, so we developed a retention pond in the southwest, in addition to the one in the southeast. So our road design, the design roads for the entire neighborhood would be 25 miles per hour. The maximum allowable grade given by our mentors would be 5% for just convenience of the neighborhood owner. We wanted to minimize the high and low points. Our site was fairly flat, so we had to create high and low points to prevent ponding and such like that. And we were also tasked with having no road crowd. We had a 10-foot wide road with a 2-foot gutter pan, 3-foot utility space, and a 5-foot sidewalk with a 3-to-1 daylight line extending out to driveways and new mud terrain. The roads, our roads that we designed were between 1.5% and 5% slope. Driveways for residents, 1.5 to 2% slope. Our ponds were graded to 3 to 1. Grassy areas were graded to a maximum of 3.1, 3 to 1. There's 5% slope for the first 10 feet away from all buildings, so they would plateau, water flow away from them. And there's swales that would guide water to retention ponds and prevent runoff from our own site to others. We're graded at 3 to 1 slope. We had 2 basic drainage basins, as I've said, to our retention ponds in the bottom corners. We developed 3 swales designed to aid with conveying the water to them. For our module, we were tasked with just doing a swale for one set of the buildings. As you can see, there's other buildings, but for just our module, we did the northernmost one, and that's a typical swale that would have gone around all these buildings so that water would navigate around them as it flows to the southern part of the site.
Learning Module 3 focused mainly on stormwater design for our site. One of the biggest problems that we faced is that most of the site drained toward the west, where we already had an existing pond that we were going to use as a retention pond on the southeastern corner. So our goal was to split the site more in half and get as much as we possibly could to drain to the southeast. We had to design, size, and place all inlets, pipes, and manholes on the site for this learning module. And the goal was to increase the time of concentration to pre-development levels while decreasing the flow to pre-development levels. We broke up our site into an east and west drainage basin. As you can see, we kind of focused everything so we can get as much as we could to the southeast pond. We had several swales that would prevent water from running off the site and would direct water toward the retention pond. And for the last slide, our time of concentration for the southeastern retention pond was 1.34 hours pre-development and 0.8 hours after, giving us a pond size of 742 cubic yards, while the western side, the time of concentration for pre-development was 2.58 hours, and post-development was 2.25 hours, giving us a size of 512 cubic yards. Once we found the time of concentration and the runoff rates, the next step was to size and place the pipes and inlets. We ended up with a total of 35 inlets, pipes ranging from 15 inches to 30 inches, or approximately 3,000 feet of pipe. We were able to maintain gravity flow, which is key in the sewer system. One of the only issues that we ran into was we're not able to speed at one spot, which is inlet 22, which is right here. So we have to install a drop inlet to decrease the speed at that location. When placing inlets, we had 3 main key areas that we focused on: low points on roads, low points in the grass, and intersections. Inlet 2 represents a low point on the road, inlet 13 is a low point in the grass, and inlet 22 and these surrounding inlets are placed for the intersection.
For learning module 4, our goals were to lay out the water and sanitary sewer lines, and as well as that, do the erosion and sediment control phase 1 and 2. So this is just the connections right now. We only utilize the sanitary one in the northwest corner. We didn't use the existing connection on the south, and we used both water connections. For the water, we try to loop as much as possible to save money. However, we did have 2 dead ends on site, which we tied off with blow-off valves. And mostly, we were able to stop intersections. However, we did have one intersection where the sewer came above the water, and we solved that problem with a concrete pipe. And our fire flow was 13,275 gallons per minute with 6 hydrants separated across the site, so we were able to cover the whole site with only 6. And it's a pressure network, so we didn't have to worry about any gravity. And for this, we used an 8-inch paddle iron pipe. For the sanitary sewer, we had a peak hour factor of 4. Pipes sized using the peak flow from units. Since it's gravity-based and we're draining to the northwest corner, we had to maintain a speed of 2 to 10 feet per second, which we were able to, and we used an 8 to 12 inch pipe here. For phase 1 of the sediment control plan, it was just construction entrances, which we used existing ones, up in Defender Drive in the northwest and Poland Drive. And silk fence was all around the site. And then we also had sediment basins, sediment traps, and control channels. Phase 2, we kept all of the implements from Phase 1 in place, but also added inlet protection, check dams, and temporary and permanent seating. And as a cost summary, just the materials, solely on material costs, such as pipes, paved surface, we came up with $2,128,000. Any questions?
You had 13,000 GPM for your fire flow. First of all, is that correct? That seems really high. And also, if that is correct, were you really able to provide that through your system?
Essentially, we assumed that we went by floor. We have like 4 floors, so our area in the calculation was really large. And we have like a small area, but a lot of floors. We assumed that's how we calculated it. The number does seem large. And I'm not sure if we were successful in honestly.
Bill, you guys have any questions for him? Can you guys run through and introduce yourselves again, your name?
Yeah, I'm Jared Tenlinas.
Andrew Coggin.
James McNamara.
And Lawrence Osborne.
Okay. Thank you guys.